Hi, my name is Medhat Al-Masri. In this video, I will demonstrate how to build a basic MCP server and client using ASP.NET and server-sent events. The MCP server exposes tools that can be discovered and used by LLMs, while the client Web API application connects these tools to the GitHub Models AI service. Before we proceed, make sure that you have a GitHub account, you've installed the latest version of Visual Studio Code, you have .NET 9 or later, and you need to also have the .NET EF tool to work with Entity Framework. In a working directory, I'm going to create a .NET solution containing two projects. The first project is going to be a simple web project, and that will be our server. The second project is going to be a client project, and it will be based on the Web API template. You can grab the instructions from this gist. I will be putting the links to all the gists that I'm using in today's tutorial at the bottom of this video. Let me go to this location. It will take me to this page, and I will click on row. Let's just have a look at what's happening here. I'm creating a folder called ASP MCP. I go into that folder, I create a new solution, and then I create a web app called server MCP. I add that to the solution. I go into the server MCP folder and I add all these packages that I need. Then I change to the parent folder and I add a web API based on controllers, and the name is client MCP. I add client MCP to the solution. I change into the client MCP folder, add all these packages that I need, and then I go back to the parent folder. So what we can do is copy all of this and go into the working directory and run it. It will create for us our solution and projects. And at this stage, it is done. If I look at the contents of the folder, you will see that there is a solution file and two subfolders, one for the client and one for the server. I will open up my solution in VS Code. This is what it will look like. And I'm going to go down to the Solution Explorer tab. You have your solution level, and then you've got your project level. This is the client project. This is the server project. We will first build our server project. I will expand server MCP and go into the program.cs file. I will need to add a service to the program.cs to turn it into an MCP server, and the code for that looks like this. So I will copy this and I will put it before line 2, and it goes right at this spot. In addition, I will need to add some middleware here. So I'll just say add MCP middleware, and the code for that is simply app.mapMCP. Now I really don't need this hello world line, so I'm going to get rid of line 9 so we don't have a lot of baggage that is not going to help us. We're going to create some MCP tools, so I will create a folder called MCP tools, and my sample MCP tool will be called the greeting tool. So I'll create a new class here. I'll call it greeting tool. And the contents of the greeting tool will look like this. Let me resolve these namespaces first. We have a class called greeting tool. It's annotated as an MCP server tool type. And there's only one method other than the constructor, and the method is called echo. This gets annotated with the MCP server tool. It's got a description. Now the description is important because it helps the AI detect the correct methods that will serve the request. So in this particular case, it is a description that says hello to a user. The name of the method is echo. It takes as an argument a username which is of type string. All the method does is it concatenates hello to the username and returns that string. Believe it or not, this is all we need to do to set up the server. But without the client, it is not very useful. Once we've determined that the server is running, we should start building our client to interact with it properly. Let's start the server. To start the server, we need to go into the server folder and type in .NET Watch. This page gets loaded in your default browser and it appears to show an error. The reason we have an error is because this server uses server-sent events. You might ask, what are server-sent events? Well, server-sent events transport enables server-to-client streaming with HTTP post for client-to-server communication. This approach facilitates communication between front-end microservices and back-end business context through the MCP server. So if you want to see something that is useful, you would have to type SSE at the end of the address. And you see something here that says, I've got an endpoint event. We need to consume this for it to make any sense to us. So let us turn our attention to the client project. So I'm going to collapse the server MCP project and expand the client project. We need to set up some configuration in the app settings.json file. I will add this configuration here. I added an AI block. We're going to use GitHub Models because it's free for anybody who has a GitHub account, and the model I will be using is GPT-4o Mini. The endpoint has to be this if you're using GitHub Models. For API key, you need to put your personal access token here, which you can obtain from GitHub. And the MCP service URI is actually the link of the server. And if you look at the link of the server here, the port number is 5205. So we need to update this to 5205 for this to work, /SSE. We will need to add some services to our client program.cs file. First, we should read the app settings.json values that we require. We're going to read the endpoint value, the API key value, and the model name value and put them into these respective variables. Then we're going to add a chat client. We're going to instantiate a chat builder, which will be using the API key and the endpoints. Let's resolve these namespaces. To be correct, the GPT-4o string should be replaced with the model variable. So let's do that. I'm just going to copy model and replace GPT-4o with the model variable. Since this is a web API project, you can see here that the OpenAPI service is added, but we do not get a UI for our API automatically. It would be nice if we have a Swagger UI. So to do that, you would have to come under map OpenAPI and add this code here. This is where we're going to add the Swagger UI middleware, and we give it a name. This is the endpoint for the JSON file, and this command makes it such that the root of our website loads the Swagger UI. If we want the Swagger UI to be loaded automatically in the browser, there's one small change we can do, and that would be going under Properties, Launch Settings. We just need to change Launch Browser to True under HTTP, and the same thing under HTTPS. Let us try our client app to see whether the Swagger UI is loading automatically. I'm opening another terminal window, and I will go into the client folder and do a .NET Watch. And you will see that this is loading automatically in the browser with the Swagger UI. Of course, we can test this out. It should give us the weather forecast API. In our client app, you will notice that this is a web API application based on controllers. We need to add a chat controller that's going to be the recipient of prompts. I'm going to add a new file in the controllers folder. It's a class and I'll call it chat controller. You can go to this gist to get the code for the chat controller. And here it is. I will click on row and grab all this code and paste it in the chat controller. Let's resolve all these namespaces first. Let's have a look at this. This here is the constructor, and there's some dependency injection going on here for logger for the chat client, which is registered in program.cs, and the configuration. There is an action method here called chat, and it responds to post. It receives a message. We create an SSE client transport here, and the address of the service is picked up from the appsettings.json. That constitutes our endpoint. Next, we get a list of all the tools that are available. There is actually just one tool in this particular MCP server, and it's called Echo. So this is where we actually process the message. The important thing here is we set up a collection of messages. We add our message to that collection, and it is at this point that we make a request to the AI model. It returns a response. We add that response to the collection of results, and we return the result. Back in my appsettings.json, I need to replace this with a legitimate personal access token. I just replaced the value for API key with a legitimate personal access token. We are at a stage now to test out our client. Let me restart the client and go back to my Swagger UI, and you will see here that I have a chat endpoint that uses post. Let me try it out. If I come here and enter something like my name, and I'll click on execute, and you can see that it has indeed sent my name to the MCP server, and it came back with hello Medhat. So we know that our server works. Now let us do something that is more realistic. We will add a database to the server project. Thereafter, our MCP client can query the database using natural language. This is very compelling for line of business applications. I will shut down the client and also shut down the server. We have to work a little bit on the server side. To keep it simple, we're just going to use SQLite. Now, since we're going to be using SQLite, there are some packages that we need to add. We need to add entity framework packages, and there is a package here at the bottom. It's called the CSV helper, and that is because I'm going to load some sample data from a CSV file and seed the database with that data. I'm going to copy these and paste them in the terminal window to add all of these packages. I will need to add a connection string in my server appsettings.json, which is this one here. The connection string would be a simple SQLite connection string, which looks like this. So the database name is going to be called beverages.sqlite, and we're going to use shared cache. Now the reason I'm calling it beverages SQLite is because I have some sample data in a CSV file that pertains to beverages. You can find the sample beverages.csv file at this gist, and this is what you're going to see. It's got beverage ID, the name of the beverage like Coca-Cola, Pepsi, and so on, the type, soft drink, tea, coffee, main ingredient, there's some that is sugar, fruit, tequila, and so on and so forth, and the origin of this beverage. So you have origin from the United States, from India, from China, and so on and so forth, and the calories per serving. Some are high on calories, some have 0 calories. So let us click on row here, copy it. So I'm going to create a folder here called www.root, and in that folder I'll create a text file, in this case custom file, and I'll call it beverages.csv, and I'll paste the data that I have. To represent one of these rows, I will create a class with these property names. On the server, I'll create a folder called Models, and in that folder I'll create a class called Beverage. And the code will look like this. Let me resolve this namespace first. So we have a class called Beverage, and these are the properties: beverage ID, name, type, main ingredient, origin, calories per serving. Since we are interacting with a database, we definitely need to have an entity framework database context. To that end, I will create a folder in the server project, and let me call it data. I will add a database context class to the data folder. So I'll add a class ApplicationDbContext here. Now the code for the ApplicationDbContext can be found at this gist. I'm gonna click on row and grab all of this and paste it for this class. Let me resolve all of these namespaces first. Looking at the code here, we're going to create a beverages table in the database, which is db set of beverage. This is the constructor. This is the onModel creating method, which essentially is responsible for creating the schema and seeding the data. So you see here that this line seeds the data. It gets its data from this method called getBeverages. GetBeverages reads the CSV file that's in the www.root folder, and using this CSV reader, which is one of the packages that we installed, it reads the CSV file and returns a list of beverage objects, and that gets used to seed the database. We need to register ApplicationDbContext for dependency injection, and that is done in the server program.cs, and since it's a service, it goes above line number 9 here. So I'll paste that code. Here we read the connection string and we register ApplicationDbContext for dependency injection, and of course we're using SQLite. I'm going to add some optional code under app run, and this code here simply applies the database migrations on startup. Now we are ready to create a database migration and apply the migration. So I will go into the server terminal window, and I'm going to run a command that requires the .NET EF tool. If you do not have that tool, you simply have to add it with this command: .NET tool install, and you want to install it globally, and the name of the tool is .NET-EF. Now, since I already have that tool, it says it's already installed. With this tool, we're going to add a migration. So the command for that is .NET-EF migrations add, and we give it a name. I'm just going to call it M1 for migration 1. I want the output directory to be data/migrations. This command will create the migrations under the data folder. So back in the terminal window, let us execute this command. Now we don't really need to apply the migrations because we added some code in the program.cs that applies the migrations on startup. If we didn't have this code, all we needed to do was .NET EF database update. But we don't need to do that. Let us start our server application just to make sure that the database is populated. So I'm going to type in .NET watch. If I go to the database, I'm going to go in the first tab here, and you can see that I have the database. I have installed a SQLite extension by Alex CVZZ. So I can come here, right click on it, and choose Open Database. But note that I am not in the Solution Explorer tab because it doesn't work there. It only works in the first tab at the top. Let's open the database. Let's go into SQLite Explorer. Let's just look at the data. You can see that there is some data in the database. I will stop the server app because there's still more work to do. We need to create some MCP tooling that allows us to query this database. I will have a service class that would be responsible for reading data from the database, and I will call that the BeverageService class. For that, I will create a folder called Services, and in that Services folder, I will add a class called BeverageService. You will find the code for BeverageService at this gist. I will go to that gist. I'll click on row, copy this code, come over to the class, and paste. Let me just resolve these namespaces here. So looking at these methods, we have a method here that gets all the beverages and converts it to JSON using the JSON serializer class. And then this gets a beverage by ID. This gets beverages by name, like Coca-Cola. This gets it by type, and the different types are pop, tea, coffee, and so on. This gets it by ingredient. Some of the ingredients are sugar, fruit, and so on. And this gets it by calories less than or equal to. You want to know which beverages have less than 150 calories per serving. And finally, it gives you beverages by origin. At this stage, we have not really exposed Beverages MCP tooling. And this is because if you look under MCP tools, we had this file called greeting tool. So we need to create a class called BeverageTools under MCP tools. You will find the code for BeverageTools at this gist. Here it is. Get the row code and paste it in my application right here. And then let's just resolve all these namespaces. So we have here the constructor with dependency injection, the ApplicationDbContext, and we instantiate the beverage service in the constructor. These are all the methods being exposed as MCP tools. Each method is annotated with mcp.server tool. It's got a good description. In this case, the get beverages JSON doesn't take any arguments. But if it does take an argument, it's good to have a description at the level of the method and a description for every argument so that it helps the AI model. So in this case, the ID of the beverage to get details for, and you have, takes an ID. All of these are methods that expose the methods in the service class so that they become tooling for our MCP server. We can test our application now. Note that in order to add more database functionality to our solution, all we had to do is add more logic into the server project. But we don't need to touch the client project because all the client project does is it receives a prompt and passes it to the LLM, and the LLM is aware of the MCP server, so it uses the MCP server. To test this app, we need to start the server first. So I'll do that with .NET Watch, and then I will start the client. Now when the client starts, it opens for me the Swagger UI. And in here, let me click on chat and try it out. And instead of string, I will say beverages high in calories. So it should tell me which beverages are high in calories. Let's find out. Here are some beverages that are high in calories. Let me ask it something else. Beverages from Japan, for example. and here they are. The only beverage from Japan is matcha latte. I hope you found this video useful, and I'm really curious about how far you can take this technology, because the sky is really the limit. Thank you, and I look forward to seeing you in the next video. Meantime, all the best.